Hello and welcome to Physics in Montana 403. Today we're going to take a look at motion graphs based on the motion of a cart moving on a track. We call this green car a cart because it is designed to hold masses on top, so that's why you may refer to it with either word, but I tend to call it a cart. We have a very low friction track. At one end of it is a sonic motion detector. The sonic motion detector does echolocation the way a bat or a dolphin would do when hunting. That is, it emits a sound, and if it hits something, it will bounce off of that object, go back to the motion detector, and the computer will be able to help us figure out how fast that object must have been moving. So you'll see, I won't let the cart get that close to it, but it's able to pick up the fact that the echo of its signal is bouncing off the cart. The reason the computer is going to be able to help us today is we have a lab interface connecting our sensor, the sonic motion detector, to the computer. That's our LabQuest Mini. So on the computer, I'm seeing graphs generated, sorry about the flicker, of position versus time over a graph of velocity versus time. And you can see I also have a data column on the left-hand side. You don't need to worry too much about what the data column says or the position says, because the position there shown is only for one instant, and we are focusing on the shapes of graphs today. You're going to have to decide when you look at a graph, was the motion detector at the top or the bottom of a ramp? Was there a ramp or was the track level? Right now I have the ramp made by putting one end of the track onto a stack of books underneath that towel over there on the left. So it's possible for me to start the cart at the bottom with the motion detector at the top and give it a gentle push, as I did to make the graphs that you were just looking at. But it's also possible for me to put the cart at the top of the ramp and just let it roll down, or to make the ramp level, or to put the motion detector at the bottom of a ramp, in which case I could have the cart start at the bottom and push it away from the motion detector, or I could have the cart at the top and let it roll toward the motion detector. It's going to be your job to figure out what kind of motion these graphs are showing. First of all, constant speed or accelerated motion. And then secondly, where was the motion detector? To do that best, you need to understand the motion detector has a frame of reference. It thinks it is the center of the universe. That is, it thinks that wherever the motion detector is 0, 0. So what do you think the sign of the motion will be, the velocity will be, when a cart is moving toward the motion detector if the motion detector thinks it is the origin?